So we've got a Lagrange equation now. Next step, what is the optimal capacity for the theater? Okay, so now this is where it's going to get tricky. So first thing we're going to do is we're going to take all of our derivatives. So we're going to take the derivative with respect to Q1. So with respect to Q1, I'm going to get 158 minus 2 times 0.5 gives me 1, Q1. So those are these terms. My next Q1 term is right here. So the derivative of that is going to be minus 1 times lambda 1. So there is my first partial derivative. The derivative with respect to Q2, I've got my first terms here. So the derivative of 118 Q2 is going to be 118 minus the derivative of negative 0.5 Q2 squared is going to be negative Q2. I've got one more Q2 term here. The derivative of that is going to be negative lambda 2. Now I'm going to do the derivative with respect to kappa. So doing the derivative with respect to kappa, I've got my first kappa term here. So the derivative is going to be lambda 1. The derivative of kappa is 1 times lambda 1. I have my second kappa term here, which is the derivative is going to be lambda 2. Let's not forget this kappa term as well. The derivative is going to be negative 10. So there's my kappa terms. Now the derivative with respect to lambda 1, I have kappa minus Q1. The derivative with respect to lambda 2 is going to be kappa minus Q2. So from here, our optimization process is the same as what we've done before. We just have a third variable to contend with now. So we're going to start by assuming lambda 2 is equal to 0, that constraint 2 is non-binding. So assuming constraint 2 is lambda 2 is equal to 0, my lambda 2 here will be 0, this will be 0, and the derivative with respect to lambda 2 would also be non-existent. So then my system of equations becomes 0 is equal to 158 minus Q1 minus lambda 1. The derivative with respect to Q2, setting it to 0, I have 0 is equal to 118 minus Q2. My third equation, I get lambda 1 minus 10 is equal to 0. And the fourth equation becomes kappa minus Q1 is equal to 0. Now to solve for this system of equations, where do you guys want to begin in solving for this system of equations? Do you guys see any easy solutions, any quick solutions? This second equation, I only have one variable here. So moving Q2 over to the other side, I get Q2 is equal to 118. Any other quick solutions? That's right, the lambda 1. So over here, I only have one variable, so I'm going to move negative 10 to the other side. I get lambda 1 is equal to 10. Now I'm going to put this information into the first equation. I get 0 is equal to 158 minus Q1 minus 10. Therefore, 0 is equal to 148 minus Q1. Q1 will be equal to 148. Now I can substitute that into this last equation. I get 0 is equal to kappa minus 148. Kappa will be equal to 148. And that makes sense. If constraint 2, the second market, is non-binding, that means constraint 1 is binding, that our kappa is going to be the number of tickets sold in market 1. If this is binding, then then our capacity is going to be governed by market 1. Okay, am I done? No, I have to check my assumption. I have to check that constraint 2 is satisfied. So constraint 2 is that my quantity 2 has to be less than or equal to the capacity. So what we have here is quantity 2 is 118. Is it less than or equal to 148? Yes. So we are happy. The peak market, market 1, governs the capacity of our theater. What's the capacity of our theater going to be? What's the answer to the question? 148. What are the optimal number of seats to have in our theater? 148, our capacity. Now, what is our associated profit going to be? I would plug that into our profit equation. For the benefit of time, I'm not going to do that right now, but you can calculate what your associated profit. So 118 is what our demand in our non-peak market is going to be. So that's our other market and what their demand is going to be. Okay, now, of course, in a real theater, we would probably have a little bit of cushion on this because we would consider things like maintenance of seats, etc. So we would have our capacity a little higher than the number of seats we would make would be a little bit higher than that. That's right. What we're looking at are two separate markets, and that's why we do not combine them. These are independent-ish markets, and meaning that they happen at independent times. They don't overlap in time. They're both dependent on the capacity of the theater, but they're not dependent on each other's demand.